So last time we talked about the definition of sine and cosine functions, and we also deal with the sine and cosine of some multiples of some special angles, the multiple of the 30 degrees, 45 degrees, 90 degrees, right? And some guys ask me, how do I break this down into the sum of two parts? For example, we have the negative 13 pi over 6. So actually, you may first divide 6 by 13, then you get a quotient 2. So you have 2 times 6, and the remainder is 1, right? So in such a way, you can write this as the negative 2 times 6 plus 1 n times pi over 6. Now you divide each term of this sum by 6. So you get 2 times 6 divided by 6, you get 2. And then 1 over 6. You have the 1 over 6. And then times pi. Right? So right now, you multiply each term inside this parenthesis by negative 1. You get negative 2 and then multiply by pi, negative 2 pi, and minus pi over 6. Okay, this is how we break down this 13 pi over 6 into the sum of the two parts. And some guys are confused about the conversion. So we know if you want to convert degree measure to reading measure, say we have the 30 degrees. If I want to convert this degree measure to reading measure, then I need to multiply this guy by pi over 180 degrees, so that you can cancel this 2 degrees and then you get a real number. If you multiply this 30 degrees by 180 degrees over pi, you cannot cancel this degrees. So that means this is not right formula, right? You cannot do it this way. So now you simplify 180 divided by 30, you got a 6. So finally, you have the pi over 6. And on the contrary, if we want to convert a reading measure to a degree, then we have the pi over 3. Right now, I want to convert this reading measure to a degree measure. So I need to multiply this guy by 180 degrees over pi, so that finally I can get a degree, right? The unit is degree, not a real number. So right now you cancel this pi and this pi, and you have the 180 degrees divided by 3. Then you have the 60 degrees. Okay. About the word problem, some guys ask me, can we first do the conversion and then use the formula, then plug in all those numbers in the formula to finish the problem? Yeah, that's better. You can do all those conversion at first. Okay, for each variable, for each identity, for each quantity, you first do the conversion and convert the desired unit. For example, miles per hour, right? And then you continue with the problem. And some guys ask me, if I have the 5 pi over 3, then how do I get 5 pi over 3 equal to 2 pi minus pi over 3? So actually, you may first rewrite this as the three pi plus 2 pi over 3, right? Then you divide each term of this numerator by 3, you get the pi plus 2 pi over 3. Now you can sketch this angle. So first, we get the pi, so it's here, right? And then we have 2 pi over 3. Now tell me, which one is bigger, 2 pi over 3 or half pi? Which one is bigger? 2 pi over 3, right? So this guy is bigger than this guy. So that means this angle is in the quadrant 4, right? So finally, you should arrive here. And this part is 2 pi over 3. And together, this is the 5 pi over 3. So if the angle is in the quadrant 4, and the angle is between the 0 and 2 pi, you may try to rewrite this angle as the difference of 2 pi and its reference angle. So right now, the reference angle definitely is equal to 2 pi minus 5 pi over 3, and this is equal to 6 pi minus 5 pi over 3, and then finally you get the pi over 3. So now you move this pi over 3 to the left side, you move the 5 pi over 3 to the right side, then you get 5 pi over 3 equal to 2 pi minus pi over 3. So actually, use the position of this angle, okay, which quadrant it is in, to rewrite this angle. Another question is about the reference angle. The reference angle, so first we need to know the reference angle theta prime must be a positive acute angle. So that means this theta prime must be greater than 0 and less than the 90 degrees. Right? So cannot be a negative. And one guy asked me, how do you know the angular velocity of the problem 106 is equal to 45,000 revolution per minute? Okay, and the problem says the rod beat just turn at such velocity, right? It's the 45 revolution per minute. Revolution per minute, this is just the unit for the angular velocity. So obviously this is the angular velocity of the outside edge of the rod bead. And another question about the range of the domain of the sine and cosine function. And we know sine and cosine alpha can take any real number. So the domain, generally we use a capital D for the domain. For the sine and cosine is equal to the set of all real numbers. And we often use this symbol, this black bold R, for the set of all real numbers. This is same as the open interval from negative infinity to positive infinity. If you use set build notation, this is a set of x such that x is a real number. Okay?